Question number 22 from the workbook says the solution curve has been superimposed on the slope field drawn at the right. The solution for the differential equation initial condition. So first of all, this solution curve represents the y value. Okay, so the solved value of the differential equation. Now this y value, it looks like there's a vertical asymptote in here, and given the scale, looks pretty much like those horizontal asymptotes are at pi over 2 and negative pi over 2. Recognizing this graph, we really should say that y is equal to tan x. Okay, that is fairly distinctly a tan graph, and we can probably use that as our initial position. Okay, so if I can guess what the solution equation is based on the graph that was drawn through the slope field, I can then work out what y prime is. So my y prime value is equal to secant squared x. Now the problem is secant squared x is none of these, and furthermore, I have a function here where the derivative is expressed in terms of y, or as an implicit function. Okay, so to be able to solve this then, what we could do is use an identity. And there's an identity that says that secant squared x is equal to 1 plus tan squared x. Well, if that's the case, well, y prime is secant squared. Okay, so y prime, I could just replace this secant squared. I'm just going to highlight it. Oops. I'm going to highlight that. I could replace the secant squared with a y prime. So I'm just going to replace that with y prime. This becomes y prime. Okay, so just highlighting that. This is this, and this is what I get here. And we also know that tan squared is, use a different color here, we've expressed y equals to tan x. So tan squared can be expressed with y prime. So I'm going to end up with 1 plus y squared. Okay, and that y squared came from the tan x. Well, if that's the case, then this solution matches E. It matches E. And the initial condition, yeah, that definitely is 0, 0 here. So it must be E.